Welcome to Metals and Non-Metals. We'll explore their properties, reactivity, corrosion, and real-life uses. Metals are like superheroes, strong, shiny, and good at conducting electricity. Non-metals are the thinkers, essential for life.
Physical properties of metals. Metals are lustrous means they have a shiny appearance. Example is gold. Metals are malleable, means they can be pressed into thin sheets without breaking. Example aluminium and iron. Metals are ductile, means they can be stretched into thin wires. Example copper and silver. Metals are excellent conductors of heat and electricity. Example copper, which is used for electrical applications. Metals have high melting and boiling point. Example is iron. Chemical properties of metals. Metals have an electropositive character, means they tend to lose electrons in reactions to form positive ions. Sodium ion is an example. The reaction of metal with oxygen typically form metal oxides. Example is magnesium oxide. Metals react with water to produce hydrogen gas. Metals reacts with acids and produce hydrogen gas. Physical properties of non-metals. Non-metals like carbon is solid. Bromine exist as liquid and oxygen exist as gas at room temperature. Non-metals are neither malleable or ductile. Most non-metals are soft and brittle. Non-metals are typically poor conductors of heat and electricity, but graphite, a non-metals, is an exception to this property. Chemical properties of non-metals. Non-metals have high electronegativity and high ionization energy. It means they hold on to their electrons strongly and do not want to lose it. Non-metals react with oxygen to form acidic oxides. Example is carbon dioxide. Non-metals reacts with hydrogen to form hydrides. Example is water. While spotting a tiger, one person quickly run away. Another person paused some moment to think and then start running. The third person stayed calm and did not bother the tiger. So three people react to the same situation differently. Running was the reaction. This is how reactivity series works. The series is from most reactive to least reactive. Here losing electrons and form positive ions is the reaction. A reactivity series is a list of metals arranged in order of their chemical reactivity, from the most reactive to the least reactive. The metal potassium is on top as it reacts rapidly with substances like water and acids. Next is sodium, which also reacts faster. Then calcium, which also reacts less faster than sodium, and so on. Gold and platinum do not react with water, so they are least reactive metals. We know metals sodium lose electrons easily and become positive ions or cations. Non-metals like chlorine gain those electrons and become negative ions or anions. The attraction between anions and cations form the ionic compound, and the bonding is ionic bond. Example sodium loses one electron and becomes sodium ion, which is positive, and chlorine gains one electron and becomes chlorine ion. Together they form sodium chloride. Properties of ionic compounds. 1. High melting point. 2. Conduct electricity when dissolved. 3. Soluble in water. 4. Brittle. Example, sodium chloride, magnesium oxide. The metals that we use is not found as a shiny piece from the ground. Metal is actually present in the form of ores mixed with other substances. So we need to extract metal from their ores using metallurgical process. Metallurgy is the science of extracting metals from their natural ores and preparing them for use. The basic metallurgical process in simple steps. 1. Crush and clean the ore to remove dirt and unwanted material named gangue using methods like washing. 2. Change it to metal oxide, by heating carbonate, which is called calcination, or by heating sulfide ores in air, which is called roasting. 3. Reduce the oxide to metal to remove oxygen using smelting where carbon is used. Reducing oxide to metal can also be done using electrolysis. 4. Purify the metal using refining. Corrosion. Corrosion means metals slowly getting spoiled when they react with air, water, or other things around them. Examples: rusting of iron to reddish-brown color. Copper turns green, silver turns black. Rusting of iron. When iron is kept in air and moisture, it forms a reddish-brown powder called rust. Rusting is harmful and need prevention. So, how to prevent rust? If we paint, grease or oil the metal, it is called barrier protection. This is to stop air or water from touching iron. Next, we can protect iron by tinning. Covering iron with a thin layer of tin is called tinning. Covering iron with zinc is called galvanization. Next, we can protect iron by making alloys. Alloy is a mixture of metal plus non-metal. Alloys are stronger and resist corrosion better than pure metals. For example, alloy or carbon with iron gives steel, which is strong. Alloy of copper with zinc gives brass. Alloy of copper with tin gives bronze. Video by Anand Mohandas.